Hello everyone, I am Sanat Kumar from the Department of Chemistry, IIT Kanpur, and today I'll be taking 11th lecture on continuity and differentiability. So the thing that we are going to discuss today is derivative of inverse trigonometric functions. So derivatives of inverse trigonometric functions. We are well acquainted with the inverse trigonometric functions: sine inverse, cos inverse, tan inverse, cot inverse, cosec inverse, and sec inverse. So, and we already have studied in our functions chapter that a function needs to be 1, 1, and on 2 for the inverse function to exist. So, we already know that the sine function has a range from -1 plus 1 and has a domain from minus pi by 2 to pi by 2. So, in case of inverse trigonometric function, what we will do, we will just restrict the domain, means range of the function, so that it can be 1, 1, and on 2. So what we will do, we'll first write down the domain and range of the functions for the sake of completeness, and then we'll proceed. So the domain of the function, range. For sine function, the domain is from, means the domain is from minus infinity to plus infinity, but for the function to be 1, 1, and on 2, we'll restrict the range of the function of sine inverse to be from minus pi by 2 to pi by 2, because after that the sine function keeps on repeating its value. That's why we are restricting its range, and the sine function's range is from -1 to +1, so this will be the domain of the sine inverse function. Similarly, for cos inverse x, it will be again from -1 to +1, and the range will be 0 to pi. We already know that domain of cos function is from minus infinity to plus infinity, but in order to make the function inverse function 1, 1, and on 2, we will restrict the range of the function so that it can be 1, 1, on 2. So the next is tan inverse function. For this function, we already know that the graph looks like this, which goes from minus infinity to plus infinity. So the domain of this function will be R, and the range will be minus pi by 2 to pi by 2. Both the endpoints excluded. Similarly, for cot inverse x, the domain will be come from for all the real number, and the range will be 0 to pi. Both the points excluded. So the next is cosec inverse x, which has domain from all the real numbers excluding 1 and -1, because at the x point the sign values are not is equal to 1 0 by 1 by 0, so undefined form. That's why these points are excluded, and the range will be -0. 0 won't be there because the sine functions, cosec functions, cosec x function does not have domain is equal to 0. The next is sec inverse x, which has again the same domain, and the range will be from 0 to pi, excluding pi by 2. So let's move to the derivatives of these functions. So let's say we have a function y is equal to sine inverse x. So what we'll do, we'll just make the function to be sine function. Let's say y is equal to sine inverse x. This implies x can be written as sine of y, because the function we have already made it 1, 1, on 2 by restricting its domain and range. So this will be like this. Now what we have to do, we have to find dy dx of sine inverse x, which is sine is different derivative of sine inverse y, sine inverse x. So what we will do, we will differentiate both the sides with respect to x. Differentiating one with respect to x. So dx by dx will be equal to dy dx of sine y. This is what we have. What we will do, we will apply the chain rule. Times this dy by dx is equal to 1 by cos 1 by derivative of sine y with respect to dy, that is equal to 1 by that will be equal to cos y. Now what we will do, since we already know this identity, sine square y plus cos square y is equal to 1. This implies cos y will be equal to 1 minus sine square y square root. So we will replace this thing here. So this will be equal to 1 by 1 minus sine square y under root. So this will be equal to, we already know that x is equal to sine y. That is what we have done. So we will replace it. So the thing will become 1 by 1 minus x square. So this is the derivative of sine y. Now let's move to cos inverse x. Y is equal to cos inverse x. So what we will do, we'll write x as a function of y. The next thing we are supposed to do, we have to take derivative with respect to x. So this is R2. So we'll do derivative on both the sides with respect to x. That will be equal to 1, and the derivative of cos y, what we'll do, we'll use a chain rule. That is derivative of cos y with respect to y times dy by dx. This implies dy by dx will be equal to 1 by d. This will be equal to minus sin x. Let's reduce the number of steps. So this will be minus sin y. Again, what we will do, we'll use a similar trick that we did. Since sin square y plus cos square y is equal to 1, this implies sin y will be equal to 1 minus cos square y root. So what we will do, we'll simply write it down as minus square root of cos square y. And from 2, we already know that this minus can be written in the numerator if we rationalize it. So this thing will become 1 minus x square from 2. So this is the derivative of y with respect to x, where y is equal to cos inverse x. So next we will move to tan inverse. Let's say y is equal to tan inverse x. This implies we will do the similar thing. We will write x in the form of y and take the derivative dx by dx will be equal to d by dx of tan y, that will be equal to times dy by dx. Now we'll do the similar thing. We already know the derivative of y with tan y with respect to y will be equal to sec square y times dy by dx, and we already know this thing is equal to 1. So we'll keep dy by dx on one side and write it as this thing. And we already know 1 plus this identity we have learned from trigonometry chapter, that 1 plus tan square y will be equal to sec square y. So we will substitute it with tan square y, and we already know x is equal to tan y. So this can be written as this. So this is our derivative of y of tan inverse x with respect to x. Now next is cot inverse y. Now we'll do the similar thing. Oh, sorry. This x can be written as cot y, and here we will use the identity 1 plus cot square x, cot square y will be equal to cosec square y. We must have learned this in the form of x, but it is just a variable which can be written as y. I mean, this identity will remain the same whether we write it x or y. The variable's name does not matter. You can substitute, means even if we write it as x, we can use the same identity here. So the variable's name is not an issue. So what we will do, we'll take the derivative of this 4 differentiating 4 with respect to x. So dx by dx will be equal to d by dx of cot y, that will be equal to 1, this will be 1, and d by dy of cot y, we are using the chain rule that we have learned earlier, and now this can be written as dy by dx times d or derivative of cot y with respect to y. Now this thing we already know will be equal to cosec square y times dy by dx. Now this will be equal to dy by dx will be equal to minus 1 by cosec square y, and we will use this identity that I mentioned earlier. This cosec square y will become, I mean, this is already this form. So what we will do, this will be 1 plus cot square y, that will be equal to minus 1 by cot is equal to x, so we will substitute it with x. So this is our derivative of cot inverse y, cot inverse x with respect to x. The next thing that we are going to do is find the derivative of sin inverse x with respect to x. Now this can again be written as sec of y. Now what we will do, we will take derivative with respect to x on both the sides. So let's write it as 4 or 5, whatever. Yeah, this will be 5. So derivative of x with respect to x will be equal to derivative of sec y. This will be equal to 1. This will be like, using chain rule, we'll do it again, times dy by dx. Now what we will do, dy by dx will be equal to, this thing will be equal to sec x tan x. This is what we have learned in trigonometry and in our previous derivatives that we did for trigonometric functions. So this will be equal to 1 by sec x, sec y, sorry, tan y. Now 1 by, what we have to do, whatever we are getting here, we have to make it such that it can be expressed in terms of independent variable, that is x. So what we will do, we will just substitute. We already have sec y. What we have to do, we have to substitute tan x. We already have learned this identity that 1 plus tan square y will be equal to sec square y. So tan can be written as sec square y minus 1. Let's write it down again. Sec square y minus 1 will be equal to tan square y, or sec y square, sec square y minus 1's root over will be equal to tan y. So this will be sec square y minus 1. That will be equal to 1 minus sec y times, let's substitute it with x times x square minus 1. The next one is, this is our derivative with respect to x, or sec is in sec inverse for x. Now the last one is cosec inverse. So we have y is equal to cosec inverse of x. Now x will be equal to, x can be written as cosec of y. This is what we have. This is what we were doing in the previous derivatives. So what we will do, we will first substitute the values. These are 6. So first we will differentiate and then substitute. So first we are differentiating it with respect to x. So this will become, this will be cosec y, derivative of cosec y with respect to x. This derivative of x with respect to x will be equal to 1. And again, we have to use the chain rule. So this will be dy by dx times derivative of cosec y with respect to y. I've written dy by dx before, because again the chain rule will matter, that's the same, will mean that that's the same, because it is a multiplication. So 1 will be equal to dy by dx times minus cosec x means cosec y cot y. We have learned this in our previous derivative classes. Sorry. This is what we have. Now, this can be written as dy by dx will be equal to minus 1 by cosec y cot y. Now we again will have to use the identity that we were using earlier, that 1 plus cot square y will be equal to cosec square y. So cot y, because we have x is equal to cosec y, so we have to substitute cot y in terms of cosec, so that we will have everything in terms of x. So what we'll do, first this thing will be equal to cot square y, and the next thing is cot y will be equal to root over cosec square y minus 1. So this is what we have. So this can be written as minus 1 by cosec y times cosec square y minus 1 which will be equal to minus 1 x square minus 1. Sorry, equal to minus 1 x times x square minus 1. So this is our derivative with respect to x. Now, what we can do, we'll do a few problems and then we will move to the next one. So first thing that we are going to do is example 1, which is, let's say y is equal to cos inverse of cot x. Let's say we have this function. So we can say it is a composite function where cos inverse is a function of cot x. So first thing we are going to do is to use the chain rule, and we have to find dy by dx. So what we will do, first we will do derivative with respect to x of y, which will be equal to dy by dx will be equal to d by dx of cos inverse of cot x. Now this will be equal to, first let's do substitution. Since we are using chain rule and it is a complicated function, so let's substitute the values first. So let u is equal to cot x. Therefore, dy by dx will be equal to dy du, or let's write one more step for the sake of clarity, d by dx of cos inverse. This thing will be equal to u. So this is what we have after substitution. And so first we have to find the derivative using chain rule. We will find the derivative with respect to u of cos inverse u times derivative of du with respect to x. That's what we do in chain rule. And for u, we already know u is equal to cot x. So this will be this thing. So cos inverse u, we have already learned, that is equal to 1 minus root under 1 minus x square. So there here it will be u square. This is what it is. Now times, and derivative of cot x will be equal to minus cot x, minus cosec square x. This will be equal to, now we will substitute u with cot x. So this will become minus 1 by root under 1 minus cot square x times minus cosec square x. Since minus are on both the terms, there we cancel out. So this will be minus times minus 1 times minus 1 will be equal to plus 1. So this will become cosec square x by 1 minus cot square x. Now let's do another problem and we will move to the next one, next topic. So let's say we have a function, example 2. Let's say we have a function y is equal to e to the power tan inverse of x. So here we can see it is another composite function where tan inverse x is a function of square root of x and exponential y is an exponential function of tan inverse of square root of x. So what we will do, we have to find dy by dx. Either we can do one thing using chain rule, we can solve the derivatives individually, or we can do it one step. Both are doable. If one is confident enough, one can do it in one go. Otherwise, we can do it step by step. So dy by dx will be equal to, we are differentiating both the sides with respect to x. So dy by dx of e to the power tan inverse of square root of x. So let's say we have let u is equal to tan inverse square root of x and v is equal to square root of x. We have this thing. So dy by dx will be equal to, using chain rule, we'll have d by du of e to the power u times, in place of u what we have, u is equal to tan inverse of v. So this will be y is equal to e to the power u is equal to tan inverse of v, and v is already square root of x. So we have to differentiate u in terms of x. Now again, u is equal to tan inverse v. So again, we have to add one more step, v times dv by dx, and v is equal to root of x. So this is our chain rule. We can do it in one go, or we can, whatever I wrote, we can solve the individual derivatives and multiply the end result in this derivative, and we'll get our dy by dx. Both are doable. I'll like to do it in one go to reduce the number of steps. So derivative of e to the power u will be the same, e to the power u times derivative of tan inverse v. You already know it will be equal to 1 plus v square times derivative of root of x will be equal to, it will go by d by dx of x to the power n will be equal to nx to the power n minus 1. So this is the identity that we are, derivative formula that we are using. So it will be 1 by 2 x to the power minus 1 by 2, which can be written as this thing. So this is what we have. Now what we are supposed to do, we'll substitute the values. So e to the power u will be equal to tan inverse v, and again v is equal to square root of x times 1 by v square. V is equal to square root of x. This will be equal to x times 1 by 2 root x. So this is what we have. So let's multiply them. Half root x times 1 plus x whole multiplied by e to the power tan inverse of square root of x. So this is our derivative. Now let's see what we have the next. Let's do one more example and we'll move to the next topic. Example 3, where y is equal to sec inverse of 1 plus 2x square minus 1. Let's say we have this thing. Again, it is a composite function where we have some polynomial function in the denominator. So what we will do, let's say, yeah, first we have to find dy by dx. In these things we can do substitutions. Let's see, this will be equal to d by dx of sec inverse of 2x square minus 1, this thing. Now what we will have, let u is equal to 1 by 2x square minus 1. So therefore dy by dx will be equal to derivative of second verse u with respect to u times with respect to x, which will be equal to 2x square minus 1 to the power minus 1. This thing. So this can be taken as, let's say, v is equal to 2 to the power x minus 1. This thing. So this can be written as v inverse times with respect to v and dv by dx. So this thing 2x square minus 1, this thing. Now what we will do, we'll do the derivative. This will be equal to sec square u will be equal to u square minus 1 and square 1 minus 1. This will be minus 1 v to the power minus 2. This will be equal to derivative of 2x square will be equal to 2 times 2x. So yeah, that's it. So what we are supposed to do, we'll replace the values. So this is going a bit longer than expected. So what we can do, yeah, let's this thing times minus 1 2x square minus 1 to the power minus 2, and this thing will be equal to means 4x. Now this will become, okay, this is getting too complicated. So basically this is a substitution question in R.S. Agrawal. So what they have done, they have already substituted the value and used the trigonometric identity to reduce the steps. This is going too much complicated. So better, I thought this procedure will suffice, but it is not. So what we can do, if we know the formula, we can substitute it. Let's say if we do it the other way, let's say y is equal to, I thought to do it both the ways, but it is getting too complicated. We can take the denominator and simply, let's say we have 2x square 1 by minus 1. This will be equal to this 1 minus 4x square minus this will be 2 4x square, and this will become plus 1. So okay, so that will be equal to, and this is 2x square minus 1 to the power 2 times 4x. Let's do it this way first. Let's finish it. Equal to 1 by 2x square minus 1 times square root of this thing. This will be equal to 2 to the power 4. Sorry, 4x square plus 1. Yeah, this will be equal to 4x square minus 4x to the power 4 by 2x square minus 1 whole square, and times minus 2x square minus 1's whole square times 4x. So this will be equal to 1 by 2x square minus 1 times, we can take out 2 and x. So what we are left with is square root of 1 minus x square, and by 2x square minus 1, this thing here will be 1 by minus 1 by, this thing will become 2x square. This is was minus 2, so this will be square times 4x. So what we have here, this term, and this term will get cancelled. this thing and this thing will become 2. So this will be equal to minus 2, and here will be 1 minus x square. I think this should be the answer. Yeah, this is. But it is way too complicated. So if we know the form, what we can do, we can simply substitute it, because it took me 2 pages to solve the single problem. So if we do the substitution, let's see how it goes. Y is equal to sec inverse 2x square minus 1. So let x is equal to cos of, let's say, a. Now what we'll do, we'll substitute x in this function and see how it goes. This will be equal to 2 cos square a minus 1. So we already know 2 cos square a minus 1 is equal to, this is formula of cos square of, cos 2a, because cos 2x is equal to cos square x minus sin square x, which can also be written in this form. So this is what we have. So what we will do, we will simply substitute. So this will become this thing minus 1 by 1 minus, this will be cos 2a, and this will again reduce to sec of 2a, and now these are the inverse functions, so this will become 2a. Now what we have to do, dy by dx, that is equal to cos inverse of x. This implies a is equal to cos inverse of x. So dy by dx will be equal to d by dx of 2 cos inverse x, that will be equal to 2 by 1 minus x square, so root minus 2. So we get the same thing in less number of steps. So if we are acquainted with the trigonometric identities, and if we know the form, if we can guess it, so it will reduce the number of steps and we can do it easily. So the next thing that I'm going to discuss will be differentiation of the implicit function. So derivatives of the differentiation. The implicit function is something that cannot be expressed completely in terms of independent variable. In implicit function, a function, let's say y, is said to be implicit if it cannot be expressed completely in the terms of independent variable, let's say x. So here what we'll have, that the function, whatever the equation will have, the y cannot be expressed completely in terms of x. So we have to find the derivative in such cases. Let's take an example. Let's say we have function, let's say example 1. Let's change the color of the ink. Example 1, for this one, we have, let's say, a equation x cube plus y cube is equal to 3axy. Here whatever we do, we can't write y completely in terms of x like we had earlier, where we had y on one of the sides and we had x on the other side, and doing some substitution we could express x and y in terms of x, but here it won't be the case. So what we have to do, we have to find dy by dx. We have to differentiate the same way using the same set of formulas that we have learned. What we have to do, we have to differentiate both the sides, and at the end we have to arrange the equation such that we get dy by dx on one side and the rest of the things on the other side. So let's proceed. So differentiating both the sides with respect to x. So d by dx of x cube plus y cube will be equal to d by dx of 3axy. Now this implies d by dx of x cube plus d by dy of y cube times dy by dx will be equal to dy dx of 3axy. This is what we have. So we have to use the multiplication multiplication formula where it was in form of u times b. So this will become 3x square. This will be 3y square times dy by dx. This thing will be 3a. First we are differentiating y with respect to x, and in the next one we'll be differentiating keeping x constant, and here we are differentiating x with respect to x keeping y constant. This was the formula. du d dash will be equal to d dash u plus d dash u, where this dash difference represents first order derivative. So this is the identity that we are using. This implies 3x square plus 3y square times dy by dx will be equal to 3ax times dy by dx plus 3ay. Now what we will do, we'll bring the dy by dx terms on one side. So 3y square minus 3y square minus this 3ax will be equal to 3ay minus 3x square. If we rearrange the equation, we'll have this thing. Now dy by dx will be equal to 3ay minus 3x square by 3y square minus 3ax. So this is the derivative, and since the 3 is both in numerator and denominator both, what we can do, we can cancel out 3 and we will have this thing. So this is our answer. Let's try another problem. Let's say we have example 2, y is equal to root over x plus 1 by root over x. So what we have to do in this question, we have to show 2 times dy by dx plus y is equal to this thing. So what we are going to do, we have to differentiate both the sides with respect to x. So we will have dy dx of square root of x plus dy dx of, this can be written as x to the power minus 1 by 2. This will be equal to 1 by 2 square root of x plus minus 1 by 2 x to the power minus 3 by 2. That will be equal to 1 by 2 root x plus 1 minus 2x square root of x. This thing. Now the question says we have to prove this thing. So 2x times dy by dx will be equal to this will become 2x times 1 by 2 root x minus 1 by 2x root x. This will be equal to, these two will cancel each other. So what we are left with is square root of x minus, and this x will cancel each other. So this will be this. So, and if we add, so we already know 2x dy by dx. This value we have already obtained, and we have to add y. This will be equal to, we had this thing from what we did here, from here, and in the question we already have square root of this thing, that will be equal to this term, and this term will add up, and this term will cancel each other. So this will be equal to 0. So this is the proof that we had to do. So this was a simple one. Let's try another one. Yeah. Let's say we have tan inverse x square minus y square by x square plus y square is equal to a, and we have to find out dy dx. So what we are supposed to do, we can, this can be written, since a is a constant, we can do x square minus y square by x square plus y square can be written as tan a. This implies dy, or we can put everything on numerator because the division will complicate the things. So this can be written as tan a. This will be constant because a is a constant. We already have x and y as variables. So x square plus y square. So differentiating with respect to x on both the sides. So this will become d by dx of x square minus y square will be equal to tan of a d by dx of x square plus y square. So this will become x square will be equal to 2x minus 2y times dy by dx using chain rule, and tan a times 2x plus 2y times dy by dx. This is what we have. Now what we will do, again we will do the similar thing. We will arrange dy by dx terms on one side. So this will be like, first rewrite the equation. Let's rewrite it. Will be equal to tan a, equal to 2x times tan a plus 2 tan a y dy by dx. So now we can bring dy by dx terms on one side. This will be equal to 2 tan a times y minus 2y is equal to 2x tan a minus 2x. This implies dy by dx is equal to, we can take 2x common in both the terms. This will be equal to tan a minus 1, and this will become 2y, we can take it common, tan a minus 1. 2 can cancel each other, so x by y by, this will, I think I made it, yeah, this should be plus. So this thing is plus, yeah, tan a plus 1 by tan a minus 1. So this is our answer. I think there is some mistake. This term will be minus this will be minus. Yeah, this will be plus. So 2x tan a minus 2x. So the x term will have minus here. This will become plus minus here. So this will be the answer. And we have to change it here also. Minus plus. So this is the answer. So we'll end this session here.